Hello! So I thought that today we could talk about a relatively simple kinematics problem, but still all the more fun, where we will be asking ourselves a couple of questions, let's see, like 6 questions. For one, our projectile, in this kinematics problem, there's often a projectile, will be shot into the air at 58 degrees at 18 meters per second. And we want to know what is the zenith, like what is its maximum point here, and how long will it remain in the air, which is actually a bit of a harder one if we have different elevations, so we'll save this one till later. Will it land on this high plateau here? And if it does, where on the plateau will it land? Okay. We're going to express this all in coordinates. And what angle will it land at, and what velocity? Again, this is a final answer. That will be answered after the other ones. So for one, what is the zenith? Well, to know all of this, we need to break this down into 2 equations for the y and the x. So for our y, our differential equation for y, and our differential equation for x will have 2 different values, which will basically be where we determine it is in a trajectory at any point. So the y, knowing down on how to break up vectors, is the sine of 58, basically the ratio of 58 to the hypotenuse 18. We're expressing this in velocity, not distance. So the sine of 58 times 18 to find the y side. So that will be our initial y velocity. Gotta not write crooked. Okay, so 18 times the sine of 58. You can put this in parentheses too, but it doesn't really matter. And our t, of course, because we'll have to multiply times t to find the displacement here. Y is a function of t and x is a function of t. And then our x will be kind of inverted. This will be the cosine of 58. It makes sense. It's not actually inverted. But that's not our whole equation. We also have a couple of different factors here. For one, we start from a given coordinate place. So our x starts from 1, 2, 3, 4.5. So we add 4.5 for when our t is equal to 0. We're still at 4.5. T being time, of course. And that has nothing to do with time. That's there regardless of how crooked my equations are. And that's all we have for the x. Nothing else is happening. Our y also has a similar value like that. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus 11, but we also have gravity here, which is expressed as negative 4.9 t squared. The force of gravity is actually 9.8, approximately, but because we're dealing with kinematics, that breaks this down into gravity over a half times t squared, which is 4.9 t squared. And there are our equations, and if we want to express them a little bit better, we could rearrange them so that it looks more quadratic, which is what it is. So this here is our A, right? This is our C, and this is our B, right? These different coefficients, just like in a quadratic equation. But right now our question is, what is the zenith? And this is actually a relatively simple answer if we're only trying to find the zenith and not where it lands. So basically it'll be symmetrical across, and the zenith is when it reaches a velocity of 0, because that's when the translation from up to down happens. So all we need to know is how many times the acceleration goes into the velocity. So basically, our zenith will be the point when time is equal to 18 times the sine of 58, basically divided by 9.8, our gravity. And that's how much time is going to pass. So our zenith, and I'd have to have a calculator for this, which I will get. Calculator. Okay, so 18, doing it here, times the sine of 58 is equal to about 15.26. So this is approximately equal to, let's see, 15.26 over 9.8. And then if we simplify that, 15.26, I don't have time to do it on the board, divided by 9.8 is about 1.56. 1.56 seconds is what's going in there. Okay, so I would like to simplify this now that we actually know the answer to 18 times the sine of 58, because it's really hard to deal with that. And that would be 15.26. 15.26. Actually, this is getting kind of messy. I just want to get rid of all this. But we already know 1.56 is our t for the zenith. So it's tz is equal to 1.56, right? And our equations we can simplify. Let's find the 18 times the cosine of 58. And this will be 9.54, right? So now we have simplified equations. 9.54. All right, and let's get rid of this. This is just kind of messy. Okay. The t is being cut off. Okay, so those are our equations. Y of t equals 15.26t plus 11 minus 4.9t squared. Now we could just graph the coordinates and find the trajectory and answer simply, but we're going to use actually a little bit more complicated math than that. And our x of t is equal to 9.54 plus 4.5. Easy enough. Okay, so our zenith is at 1.56, so all we need to do is plug 1.56 in there for t, and we find our answer. So, 15.26 times 1.56 plus 11 minus 4.9 times 1.56 squared, right? Okay, let's find what this is. So our y at this point, when we reach our zenith, should be, it's a little large, 22.88. So that's 22.88, and I'm worried about our x fitting here. And our x will be equal to 9.54 times, not plus, times 1.56 plus 4.5. Okay, 19.38. 19.38. Alright, 19.38. Let's see what that looks like. So this is our answer here. Now let's see what that looks like. I'm just going to say about 19. That's about here. And 22.88. That's about here. Okay, so let's follow these up. And that's going to be around here. So this is about a little to the right. So that's about, still, really up. There we go. So that's about the zenith in our trajectory. So this is when the tangent line, our slope, is equal to 0. So the derivative, if you prefer that, is equal to 0. So that means our trajectory is going to look something like this and then slope down. But I don't know if it will hit that. That's what we're finding now. Now to find that, what we'll need to do is use a quadratic formula. So we want to know if when our y-coordinate is equal to this elevation here, right at about, I believe it's 15, right at 15 meters, if also our x is, so we need to find when our y is equal to 15 our x has to be within the interval, which is a symbol sort of like that, of 20 to, see, 25, 26, 27, 28, 29, 30, 31. And that's a pretty wide range for what we're dealing with. So I think that we might be able to do that. So here, knowing from our quadratic equation, we can find exactly what the t is when our y of t has a value. So because our y of t is equal to 15.26t plus 11 minus 4.9t squared, when our y of t is equal to, what was it, 15? Then we just subtract 15 times the side and get the new equation. 0 is equal, because this is 0, we subtracted 15 from it, is equal to negative 4.9t squared plus 15.26t minus 4, because we subtracted that 15 from 11. Now, I cannot factor this because that is not easy. So I'm going to use my calculator and the quadratic formula. The quadratic formula states here that our t is going to be equal to negative b, 15.26, negative 15.26, plus or minus, which means we get two coordinates, which makes sense because it's quadratic. It'll cross 15 twice. We need to find probably the latter time, because the first time will only be about here. So we need to find the next. 15 plus the square root of 15.26 squared minus 4 times a, negative 4.9, times c, which is negative 4, over 2 times negative 4.8, which we know is negative 9.8. And I'm going to do this very quickly with my calculator because I do not have time to do that by hand, and it would be very tedious. Okay, so negative 15.26, I'm going to do plus first, plus the square root of 15.26 squared minus 4 times negative 4.9 times negative 4. And then I get the answer, negative 2.83, but then I have to divide the answer by negative 9.8. Okay, I wrote negative wrong. There's different symbols for minus and negative for some reason. Okay, so I get 0.29. 0.29 seconds. That's very quick. 29 hundredths of a second. But that means it's probably going to be this one. So now all we need to do is solve for the other one. I already have the equation in here. So now I'm going to switch this to minus, get the new answer, and then divide by negative 9.8 to find 2.83 seconds. And that makes sense, right? And that's a little longer than our zenith time, which, if you remember, our TZ, as I like to call it, is equal to 1.56. And then, when we get to y equals 15, 2.83 seconds will have passed. And I'm going to do a different color, because we're using this one, because it makes sense. We have to choose between our two answers, two solution points. Now, all we need to find is if if x here is between these two at that second. So now we just need to plug that in, right? 2.83 in our x equation times, where's our x equation, times 9.54 plus 4.5. All right. So we got 31. 31. Okay, we got just below 31. We landed right here on the edge. We perfectly landed. And that I was not expecting that because I had not done this problem before, actually. So, that means that we're close to not having to, but we also have to answer where, but that comes with the answer, and that would be, I'm going to do this in green, right? 3115, right on the edge. And yes, we did. Alright, so now, because we know it landed here, then we already have our answer for this one too. It only took 2.83 seconds because it landed. That was all it was in the air. So this is also easy. If it had been the ground, we'd have to do another calculation, but we got 2.83 seconds. Not negative, but 2.83. Alright, so we've answered almost all of our questions. Now come the hard ones. So, what angle will it land at, and what velocity? Now this isn't actually that hard. All we need to find is different components at that point. So, first let's find what velocity will it land at. So, basically we need to find the derivative of one function, and we know the derivative of the other function because it's incredibly easy. It's a very simple derivative. So, I'm going to do it over here. So we need to find the dx, here. It's even easier just to write it as our x prime of t is equal to, well, this is clearly, we cut out the constant, we just have 9.54. And our y prime of t is going to be a little bit more complicated, but we can still use the power rule because we have just equations that suit that. So that's negative 9.8 t to the first, right? Plus 15.26. So these are the slopes at any point along our trajectory, like the rate of change, the velocity, at any point. And our y depends on t because it's acceleration. And we can calculate that using our landing to find the speed at both these points. X of t, we know the speed is already 9.54, but for y of t, we've got to figure this out. So, 9.8, negative 9.8, negative 9.8 times 2.83 plus 15.26 is equal to, negative 12.47. And you might think that's kind of weird because we have negative velocity, but that's not. That just means we're moving downward. So this is equal to, what was it? Negative 12.47. Negative 12.47 when t is equal to 2.83. Okay, so now just using the Pythagorean theorem, if we know at that instantaneous point we're moving x at one speed and down at that speed, the speed at which we're moving down is our velocity of impact, right? So all we need to do is negative 12.47 squared plus, this is just Pythagorean theorem, 9.54 squared is going to be equal to the square of our new velocity, our final velocity squared, this is when we finally impact, or our final velocity squared is equal to square root of all of it. Which again, we have to do with our calculator, because it would take too long or it'd be impossible otherwise. Okay. Square root of negative 12.47 squared plus 9.54 squared. Oh, this is going to be, okay, it thinks I did it wrong. Square root of negative 4 plus 9.54 squared. Okay, domain error. See something wrong with that. So I'm going to fix this to a positive because it will have the same answer. Right? So let's just delete that. Okay, then we get our answer. Our answer, 15.7 meters per second. So, now, we know this. We know the velocity. We know that our velocity is 15.7 meters per second. Perfect. Now, what angle? Now, again, this is incredibly easy, and we basically answered it. To take the angle, we can just use tan, because we know that our y is something and our x is something, and we can take what angle corresponds to that ratio. So, I'm running out of space, so I'm going to erase some of this. So our arctan, our inverse tan, or if you prefer to write it a more traditional way, our tan, our tangent, arctangent, tan inverse tangent, which is kind of silly because it looks like tan to the -1. But our inverse tangent of our y velocity, which I kind of cut off here, .47 over our x velocity, 9.54, is going to be equal to our theta, which will be negative because we're moving downwards. Alright, again, calculators are very helpful, and it's not cheating if it's not possible. Okay, so the inverse tan, which I've never used on this calculator, of negative 12.47 over 9.54 is equal to, alright, okay, this is our final answer. And it's going to be a surprise. Equal to, it's going to be in pink, negative, of course it's going to be a secret forever if I forget it, 52.58 degrees. My calculator was in degree mode. So, now we know the velocity, the zenith, where it lands, if it lands, how long it's in the air, and now we know what angle. This is 52.58 degrees, and this is a really messy board, but we found all our answers. And that's how you deal with kind of finding everything on a kinematics board. Perhaps next time I'll add a couple other projectiles and see if they collide, which is a lot harder. Goodbye.